Okay, so lesson today is on solving quadratics. Solving means you're actually getting an answer. We have several words that stand for the answer, so I'm just going to list those out so that no matter what it says, you know what the vocabulary means. The most common thing that you see them called is zeros, but they are also x-intercepts. So it's like where the graph touches the x-axis, something comma zero, and that's why they're also called zeros. You also see them called roots, and that's because, as you'll see, a lot of answers involve a square root, so they are called roots. And then they are also called solutions because you're solving an equation, so it's like the answer, so it's your solution. So no matter which one of those words you see, that's what we're looking for. Okay, so I just want to real quick review our perfect squares because, again, roots come up a lot in this. And I think, I can't remember if it was this class or my other one, but somebody said, how far up do we need to know? 12 is what I require without a calculator. Okay, so if you know all the way up through 12, then you're good. People do forget about 1, so I do like to throw 1 on here. 1 squared is 1, so don't forget about that one because the square root of 1 then is 1, okay? And then 4, 9, could you guys like tell these to me? Like, do you know these? Okay. 16, good. 49, 64, 100, 121, 144. I hope that you do already know them. If not, you need to know up through 12 without a calculator. All right, now sometimes you have to square root negative numbers and you end up with what's called an imaginary number. So I is our imaginary number and it is square root of -1. It's how you get the negative underneath the square root. Did you last year in algebra 2 do all the stuff with I, like you had to do I to the 5th and 3i plus that? We're not doing that. Okay, the only thing you need to be able to do is reduce these. We're not doing all the operations with I. They took that out of the curriculum a couple years ago and I was like, because everyone always hated it. All right, so when you do this, square root of -100. Well, what's square root of 100? 10, just because it's negative, it's going to be imaginary, so 10i. The common mistake is people make the answer negative. It doesn't make the answer negative, it makes the answer imaginary. Okay, so don't make your answer negative, it makes it imaginary. Now, the rest of these we're going to have to split. So I'm going to review how to split up the roots. With me back there? Okay. So the first part, I know it sounds kind of violent, you're going to take out an I. So you're going to take out the negative part. So that's the part that's going to be I. So you take out an I. And then draw yourself 2 more little houses. So I need 2 numbers that multiply together to be 8. One of them has to be something we could actually square root. Yep, 4 and 2, good. 2 and 4, it doesn't really matter what order you put them in. People always try to make both of them work. That's not going to happen. It's a one or the other kind of thing. And then you reduce what you can, and what you can't is just left over. So it's like you do your best, and what you can't do anything with is just left over. So what is your square root of 4? 2. This part is I, and then square root of 2, bless you, is just left over. So try the next one. We're going to take out an I. So take out the part that's negative, draw 2 little houses. For the sake of time, I will tell you this one is 16, because I always get 4, but 4 works, but you want the biggest one. Do you know what it is? 16 times 3, good. And then you reduce as much as you can, leave the rest alone. So square root of 16 is 4, square root of -1 is I, and then square root of 3 is just left over. All right, so looking at that last one there, you're going to take out an I. So take out the negative part, draw 2 more little houses. I need 2 numbers that multiply to be 45. One of them has got to work. Yep, 9 times 5, perfect. And so what is your square root of 9? So it'll be 3i square root of 5. So whenever we're working out these problems, if you get a square root of a negative, that's how you reduce it. That was your quick review of I. That's all you need to be able to do with I. Are we good? Okay. Solve by graphing. There's a bunch of different methods for how you do this, and I just have a couple problems of each of them, so we're going to solve them by all the different methods. I don't foresee you doing solve by graphing unless I force you to do a graph. That's usually everybody's last choice, but I just have like 2 of each of the kind of ways that we'll do this here. So solve by graphing. This moved up how much? It moved up 8, so go up 8 and put a point. And then I'm going to make a table. Give me some more numbers to plug in. What do you want to try? Guys, we started at 0. Can you give me a number next to 0? 1. And then 2 is a good choice as well. All right, so let's do 1 and 2. 1 squared. 1 times -2, -2 plus 8, 6. So we get 1, 6, and that means you get -1, 6 because symmetry. And then if you do 2 squared, 4, good, you're the only one talking to me. 4 times -2, -8 plus 8, 0. So you get 2, 0 and -2, 0. Oh my gosh, why is the parabola upside down? Because there's a negative, and you literally just look at it and go, oh, there's my answers. Solved by graphing is you make a graph and then you look at it and you go, oh, there they are. But you have to know which part of the graph you're looking at. These are your 2 answers. Do you see them there and there? I don't have a better reason than look, there they are. So your answers are x equals -2 and x equals +2. All right, for this one, we're going to have to add or actually, I won't add the 9 over. We'll review what we did last time. I was going to add the 9 over and then I have us just plug in numbers. But you know what? We'll review what we did last time. Do you remember complete the square? You write down the first 2 terms, leave a gap. I'll use a different color. Do you remember how to complete the square? I know a weekend happened between then and now. Divide by 2 and square. Good memories. Okay. 6 divided by 2 is 3. 3 squared is 9. So do +9 on both sides. Good. We remembered from like 3 days ago. And then the idea is you want to write it as something squared. So what's going to go in the blank? It's going to be x plus a number or x minus a number. It'll be x minus because this is subtraction here. X minus 3. Good. So how did it shift? Oh, and why is it 0 on the other side? I just wrote that, but why is it 0? Yeah, -9 plus 9 is 0. So which way did it shift? Left or right? It's kind of backwards. It went right 3. So go right 3 and put a point. And then let's make a table. We'll get a few more points. What do you want to try and plug in? 2 is a good. See, we're centered at 3. So plugging in 2 is a good choice. Let's see what that gives us. 2 minus 3 is -1 squared is +1. When you square something, it's going to be positive. So you get 2, 1, and then you would also get 4, 1. And there's your parabola. Do you remember what this line is? We'll do more review of last time. Do you remember what this line is called that splits it in half? Axis of symmetry. Good. Do you remember what the center point is called? Vertex. Good. Vocabulary. You guys are quiet, but I think you listen to me. You all make eye contact with me, so it's good. All right, so what's our answer? We actually only got one answer this time. Yep, x equals 3. Only touches the x-axis in one place. If it doesn't touch the x-axis at all, that means your answers are imaginary. This is where you get I. So that's graphic. You just draw a graph, look at it. There's your answers. All right, these ones are solved by factoring. Everyone always hates when I say this, but factoring is an assumed skill. We don't cover factoring in pre-calc. I'm going to review it real fast, but it's assumed that you brought that with you from algebra 2. First step is evacuate. I call it evacuate. You want to get it so that it all equals 0. So add 4x squared. Evacuate, evacuate. Get it all equal to 0 first. And you want to put it in order. So you want the x squared part to come first, and then the x part, and then the number. Now, you don't always guess right on the first try for factoring, and that's okay. Unless you're writing with pen, in which case maybe wait until we get the right answer here. But how can you split up 4? Because you have choices. Like what multiplies together to equal 4? Yeah, 1 and 4 or 2 and 2. If we guess wrong, we will just try the other one. What do you want to try? All right, 1x and 4x. Then you look at the last number, which is 2. You don't have options there. It's only 1 times 2, but it does matter where you put them. So do you want to put the 1 in the first parenthesis, or do you want to put the 1 in the second parenthesis? You want 2 in the first one? All right, everybody just look. Let's see what we have. The outsides are giving you 1x. With me there? Insides are giving you 8x. How did I get 8? 2 times 4. So does 1 plus 8 equal 9? Yes. Get the number first, then worry about the symbols. I want them both to be negative because -1 and -8 makes -9. Hey, but Miss Cole, it's a positive 2. Yeah, that's actually good. Why is this 2 positive? When you multiply these, a negative times a negative gives you a positive. So all the symbols worked out. Now, here's the pep talk. I get a lot of people that learn how to do that. They factor beautifully and then stop. And I have to take off points because you didn't finish the problem. You have to get an answer. You're going to set both of those equal to 0. I start to try to coach you at pre-calc level to do that part in your head. If you want to write it all out, that's totally cool too. But if you set this first parenthesis equal to 0, what is x going to be? Positive 2. Good. So we get x equals 2. And if you set the other parenthesis equal to 0, you would add over the 1. So you have a 1 and then divide by 4. So it's going to give you 1/4. And again, if you want to write all those steps out, there is nothing wrong with that. I just start to try to coach people to do it in their head at this level. That's all. All right, look at the next one. What do you notice about that? They're both perfect squares. So when we split it, it's a difference of squares. So how does the 16x squared split? 4x times 4x. 49 would be 7 times 7. And what symbols do you want for your difference of squares? Negative and positive. And it doesn't matter which one you put where. And then you're going to set each of those equal to 0. You need to actually finish up the problem and get your answers. So let me cover this up. If you set that first one equal to 0, you would add 7 and then what? Divide by 4. So you get 7/4. And then what's the other one? -7/4. How are we feeling about factoring? Did factoring go well last year or like, it's not, okay. Factoring is sometimes a struggle, so that's why I just always ask. Boom. Go ahead and close your Chromebook. All right, using the square root property, let's talk about that real quick. Whenever you square root, what do you need to put in front of it? What symbol do you put in front whenever you take a square root? Plus and minus. That's your square root property. Whenever you do a square root, you're going to put a plus and minus. Other than that, it is business as usual as far as doing algebra. First step on this one, you would divide both sides by 5. Divide by 5, divide by 5. It's just solve the equation. It's like algebra 1, except there's a squared in there. So you get x plus 2 squared equals 6. And then, here I'll use another color, to get rid of the squared, you're going to square root, but you have to put a plus and minus. When you put the square root, you have to put a plus and minus. So the square root and the squared cancel. You get x plus 2 equals square root. Oh, I even just said that. Plus and minus square root of 6. Without a calculator, I don't know what that is. So, I mean, non-calculator is great. Just leave everything alone. And then what's your last step? Okay, don't write this. I'm going to show you what not to do first. You do not want to put plus and minus square root of 6 and then the -2. Can you see a potential issue with that? Like what could be a problem potentially with writing it that way? Yeah, you might confuse the 2 for being underneath the square root. So instead, when we subtract the 2 over, we write it in front instead so that it doesn't scoot underneath the square root. So you get -2 plus and minus square root of 6. So just always write that out front. That is the correct format for that. And to be clear, how many answers did we get? 2. You got -2 plus square root of 6, and you got -2 minus square root of 6. 2 answers, okay? What would you do to start solving this one? Just regular old algebra. What are we going to do to both sides? Not yet. Not yet. You guys have your steps out of order. Minus the 64, subtract 64. All those steps you guys are saying are correct. We just got them out of order. Subtract 64, then what? Divide by 2. That's going to be negative 32. And then what's your last step? Square root. What do we need to put in front of our square root? All right, good. Plus or minus. And this is exactly what we did on the front page where I showed you how to reduce them. So take out an I, it's the negative part, and I need two numbers that multiply to be 32. One of them's got to work, and as a heads up, there's two numbers that work, and we want the bigger one. 16, good, 16 and 2. Because 4 also works, but you want the bigger one. So your final answer is plus and minus, square root of 16 is 4. And then this part is I, and then square root of 2 is kind of left over. Again, how many answers did we get? 2. Okay, very good. And if you graphed that, would it touch the x-axis? It would not. If you graphed it, it would look like that because the answers are imaginary. Okay? These are the ones we did last time. Solve by completing the square. First thing I've got to do is some rearranging with this one. Can you follow me on this so we don't have to write the problem over and over again? I want to move the 2x over here, and I want to move the 10 over there. Like algebra is just moving things. So I'm going to subtract them both. Do you understand what I'm saying? That when I move them, they'll be negative? Okay, thank you for heads nodding. So it's going to be x squared minus 2x. I'm subtracting the 2x over. Leave a gap, and it would be equals negative 10. Good. We just had them swap sides. It's just we had to subtract. Divide by 2 and square. So what is 2 divided by 2? 1 squared. This one's tricky. 1 throws people off. Like if you were like, hey, that threw me off, congratulations, you're normal. Like 1 messes people up because 1 times 1 times 1 times 1 is 1. And the square root of 1 is also 1. So you know, that messes people up. So it's not just you. All right, write it as blank squared. And then what goes in the blank should be x plus a number or x minus a number. So what's going to go in there? Yeah, x minus 1. Perfect. Equals negative 9. Now, last class, that's where we stopped. I taught you to get to there. Today, we're just going to finish it up. There's 2 more steps. We're just going to keep going. How do you get rid of the squared? Square root. So that's what we did last time. Here, we're just going to like actually finish the problem. So the square root and the squared cancel. It's x minus 1 equals, oh, I put a square root. That means I need plus and minus. And what's your square root of negative 9? It's 3i. Good. And then last step, to get x by itself, you would add 1. And we do it the same as with the roots. We put it out front. That's just the like understood format. So it's 1 plus and minus 3i. If you wrote that one on the end, I mean, I wouldn't like mark it wrong, but it's just this is the accepted format. So just try to remember to put it out front. All right, we're going to try that again. This one has a 3 in front, so we're going to need to factor that out. You can divide by 3. I believe in my heart you can do it. All right. What do you get if you divide these by 3? Good. Just x squared plus 4x. Good. Leave a gap. And then equals 7. Just leave a gap there. We're going to divide by 2 and square. So what is 4 divided by 2? 2. And then 2 squared is 4. 4 is a little bit weird. When it's 4, it's still 4. A lot of people will just end up memorizing that. Like, oh, when it's a 4, I add 4. Now, on the other side, it's not 4. Why is it 12? That's correct. Then the 3 that's out front. 3 times 4 is 12. So when you add it on that side, it's plus 12. It's easy to do. It's 3 times 4, but it's also easy to forget to do. So just be careful. Work slow. Okay? So we're going to write it as 3 times something squared. Just set it up blank. Like you have your framework. You can go back and fill it in. What's going to go in the blank? Yep, x plus 2. And then that side will be 19. Cool. So that's what I taught you last time. That's what we did. When did I see you? Friday? We're just going to keep going and finish up the problem. This one's going to have 3 more steps. First thing is I need to get rid of that 3. So we're going to divide by 3. This is the beauty of no calculator. Hey guys, 19 divided by 3 without a calculator, guess what that is? 19 over 3. Like literally just leave it alone. You don't have to do anything. It just doesn't reduce. Then what? Square root. So we're going to need a plus and minus. Oh, and hey guys, what's without a calculator? What's the square root of 19 thirds? Square root of 19 thirds. Like just put a plus and minus in front of it and that's it. You can't do anything because you don't have a calculator. And then what's your last step? Good. And the minus 2 should go where? In the front. So it's -2 plus and minus square root of 19 thirds, which is a great answer. We get so many like weird, yucky looking answers in pre-calc because it's advanced math. By the end of the year, like, and I've actually had this happen during a test. Someone has come up to me and been like, I got 5 as my answer. What did I do wrong? And I'm like, nothing. Like, that's the answer. Like when the answers come out nice, people start to doubt themselves. All right, so let me recap all the methods we did. Graphing, you graph it, you just look at where it touches the x-axis. I realize you're probably not going to do that unless I force you because nobody really likes graphing. Factoring, that went well. We remember factoring from last year. Factor sum equal to 0, okay? Square root property, just remember to put a plus and minus. This is what I taught you last time. Here's your last one. Do you remember the quadratic formula or does that ring any bells? It's a formula that's about yay long, sort of. Let's see what you got. We'll write it off to the side. X equals, oh, -b. Oh, good, and there's the plus minus. Oh, good, gigantic square root. B squared, there is a minus in there. Oh, you guys know it, cool. Over 2a. I realize that you will also probably not do this unless the directions say so. You're probably going to choose like one of these shorter methods. Factoring is the shortest method, but not everything factors. You get some things that aren't factorable, and then you have to pick a different method. We're just going to do one like this and then move on, okay? I always write out what's A, B, and C. You can agree or disagree with that, but A is 2, B is 4, C is 3. I realize you can see that because I get people like, Ms. Cole, I can see that. I know, but it's a big formula, and you know, it's not about intelligence. What do I always say it's about? It's not about being smart. It's about, have I not preached about this enough in here? Oh, I do talk a lot about integrity. Maybe I say this more to my freshmen. It's about organization. It's not about being smart. It's about staying organized. Because I know people that are actual geniuses that can't get answers to stuff because it's just like number explosion. Anyway, that's my soapbox rant for today. Stay organized. All right, so -b, that would be -4 plus and minus. Draw a gigantic square root. Underneath of there, b squared. All right, that would be 4 squared, which is 16, minus, now it's 4 times a times c. So let's see what we get. 4 times 2. Well, I've got the negative in there. Let's not worry about that. 4 times a times c. 4 times 2 is 8, times 3 is 24. Good. Huge fraction bar. 2 times a. So 2 times 2 is 4. And then we got to simplify that down. So that'll be -4 plus and minus square root of, okay, 16 minus 24. It'll be -8. Good. I'm going to do that -8 as a side problem. I do a lot of margin problems because I don't like to rewrite the whole thing. I'm like, oh, I'll do this off to the side and then go back to the problem. You take out an I, and it sounds violent. Take out an I, and then how is 8 going to split? Yeah, we actually did that one on the other side of the paper. So I just write that off to the side and then put it back in the problem because otherwise you have to copy the whole thing over and it's annoying. All right, so -4 plus and minus. And what does this reduce down to? I'm just going to put that back in. Yep. 2i square root of 2 over 4. And then the last step is you divide both of these things by 4. And I just always draw little circles around them. It looks kind of like a heart. That helps people remember. So you're going to divide this part by 4, divide this part by 4. So hey guys, what is -4 divided by 4? But -1 plus and minus. Now the only part you really do here is the 2 over 4. 2/4 is a half, and then I square root of 2, which is a great answer. Don't discriminate. It's a lovely answer because it's the right answer.